pop up. There it is, so that we can share this with you afterwards. So good afternoon and welcome to our webinar Wednesday series. If you have requested a PDH credit, go ahead and make sure that your name as it's shown in here is something that I can recognize to be able to give you credit. So I do see a few people that is not quite noticeable for me. So like iPad 2, if you do need a PDH credit, go ahead and make sure you change your name on there so that we can see it and give you credit for that. So today, Bill Dietrich is going to be our presenter. He is the Senior Director of Chiller Applications and Systems at Daikin Applied, covering all air-cooled, water-cooled, centrifugal, and positive displacement machines. Prior to joining Daikin, Bill was the Vice President of Global Engineering for BAC, and he also spent many years at both McQuay and York prior to joining BAC. He has over 30 years of experience in the industry and has held numerous engineering and marketing application positions addressing commercial industrial HVAC equipment, including chillers, air handlers, rooftops, cooling towers, and evaporative condensers. He has a deep chiller background and was involved in the transition from CFCs and HCFCs to HFCs, and is actively involved in the work and discussions regarding the new low GWP refrigerants. All right, so today Bill is going to discuss how the HVAC industry is on the cusp of another refrigerant transition. Growing concern for climate change and the impacts of refrigerants used in HVAC and other applications has driven the industry to develop new solutions. There's no question that lowering HFC emissions is the right choice for the planet, and legislation to do this is in place worldwide. The two most common refrigerants we use today, R410A and R134A, will be phased out over the next 15 years. So Bill is going to discuss new options coming to the market and where they will be applied. So with that, Bill, I will turn it over to you.
Okay, thanks, Kelly, and good afternoon, everyone. Thanks for joining. And as Kelly said, I was around for the first one, so that just means I'm getting on the tail end of my career rather than the beginning. But today, we'll just hit briefly on the background and spend a bit of time on the regulatory update and just give you a view of the landscape of what's coming regarding the refrigerants, and then some talk of the alternatives. Got a list. It's a bit of an alphabet soup, and they will have a PDF of the slides available, and it may help you in the future to kind of keep these different refrigerants straight, because there's a lot of numbers and letters, and a lot of them look very similar. Then just give a quick look of what's going on in the market. You know, we started out with our CFCs and HCFCs, and really the key things we were using back in those days was R11, R12, and R22. As Kelly noted, I was around when we started transitioning those out, and we thought the HFCs were going to be here permanently with the zero ozone depletion. Then, of course, we figured out that a lot of these refrigerants are also greenhouse gases with a higher global warming potential, which just means once they're released into the atmosphere, their heat trapping capabilities is many times that of carbon dioxide. So now we're currently in the transition to looking at, we got to stay with the zero ODP. We don't want to bring back any of the ozone depletion, but we're looking at lower GWP HFCs and a new class of refrigerants called HFOs. Chemically similar to HFCs, but they're really designed to break down quicker and have less of a climate change impact when released to the atmosphere. And you know, one of the key drivers on a global basis, we had the Montreal Protocol back to get rid of the ozone depletion substances. And it was really a good example of a global treaty that worked quite well. So the consensus around the world was to make an amendment to the protocol called the KIGALI Amendment. And this addressed the phase down of HFCs and trying to use the same framework that had been established originally under the Montreal Protocol. You know, when we talk about, you hear a lot of these terms, right? Carbon footprint, electrification, decarbonization. All this stuff is really related, and it's related to the higher GWPs of refrigerants because it's all an effort to minimize emissions that get into the atmosphere and can impact climate change. You know, so you've seen ASHRAE last September on the way to decarbonization. There's a nice update in the November journal about the EPA's final rule to cut HFCs. But it's really, all these things are really related. You know, we're looking at ways to not only reduce refrigerant emissions and impact, but to reduce emissions from gas, cars, everything with the whole electrification. So the key drivers, as we look at it from an HVAC standpoint, are to maintain or improve your efficiency, because today the efficiency is really the key driver to global impact, and to now do it with the lower GWP fluids going forward. Now we'll talk a bit about what the US is doing, then California, and hit on Canada. You know, and the big news that we had back in December of 2020, that the US Congress finally passed a law, and it was the AIM Act, the American Innovation and Manufacturing Act. And this finally gave the EPA authority to regulate based on global warming. They had tried previously, and we'll hit on a couple of the rules they put together, but they are ultimately struck down in the courts because the courts determined that EPA had not been given the authority to do that regulation. So with the passing of this act in 2020, they finally did have the authority to start making laws. And really what we wanted to do, the US still has not ratified the KIGALI amendment to the protocol, but this law gives the EPA the ability to start regulating and stepping down in conjunction with what the KIGALI amendment does. You know, so just a little bit more on what the AIM Act is. It was enacted again in December of 2020, and it directs the EPA to phase down production and consumption of HFCs. And as we learned during the CFC phase out and the HCFC phase out, you know, when you talk to environmentalists, the view of a lot of people is if a pound of refrigerant is ever made, it's probably going to end up in the atmosphere at some point. There's not always a lot of confidence that it'll be reclaimed and recycled or reclaimed and destroyed. So what they found when they do these regulations, it's really to go after the source and regulate at the production end of things. And again, that's going to be the aim with the KIGALI amendment. So all these phase downs that will step through the years are really directed at the production and the consumption of the HFCs. And there'll be some regulations with specific equipment that the EPA will enact, but it's really in a measure to try to take these downward steps in the production of the product. You know, so the law required that the EPA establish their first phase down program and allowance of allocations by last October, which they did. And then they also allowed any interested parties, you know, like environmental groups or whatnot, to petition for certain regulations. And a number of groups petitioned to reinstate the old SNAP rules 20 and 21 that the EPA had tried to enact back in 2016, but were ultimately thrown out by the courts. And the rule 21 would ban the use of 134A and 410A in production of new chillers after January 1, 2024. And here is just the old fact sheet that EPA had published back in December 2016 with their final rule 21. And again, this was ultimately thrown out by the Supreme Court, but it's specifically for centrifugal and positive displacement chillers, which would be your screw compressors or your scroll or your rotary compressors. It had a whole list of refrigerants that would not be able to go into new equipment. And again, this was a step to try to reduce the use, but this does not ban the production of the refrigerants. It just says that you can't use it in these types of product after this date. And so then back in October, the EPA granted a petition from the National Resources Defense Council, the NRDC, to replicate the prohibitions in rules, SNAP rules 20 and 21. So when they did that, they essentially said, hey, you know, and today I'm mostly a chiller guy. They said that starting Jan 1, 2024, you cannot produce chillers using 134A or 410A for use in the United States. So that's coming. The final rule the final actual rules have yet to be written, but that's really what's going to happen. And this just came out the other day. There's actually a technology transitions workshop that the EPA is putting on June 30th to talk about, to take stakeholder input on the technology transition. So if anybody is interested, you could go out to the EPA website and register for this and just hear more about what they're talking about. And they have two of them. The one in the morning is really about for Rule 21, which addressed chillers, and then Rule 20 in the afternoon is more about motor vehicle air conditioning and foam use, where a lot of refrigerants are actually used. So we're moving along. The EPA is following the requirements of the AIM Act and continuing its rulemaking process. You know, I had said that they had to do some work by October of last year, and what they did is, these are the allowances for 2022, the consumption allowances. And so what they did is they look at, okay, who was using what, and based on that, they give allowances for consumption. So you can see the two biggest pieces are Honeywell and Chemours, which is the old DuPont refrigerant business. So the big refrigerant players, Arkema is another big player. So just among those three, they have basically over half of the consumption allowances for 2022 that the EPA has done. And then, you know, there's a bunch of other ones depending on what their activities were over the course of that year. And again, the EPA will now be doing this every year, setting the consumption allowances for the different companies. And here is the mechanics of the AIM Act. So if you look over here on the right-hand side of the slide, we want a 10% reduction from the baseline in 2022, then a bigger drop, a 40% reduction in 2024, a 70% reduction in 2029, 80% in 34, and 85% in 36. So you can see on these charts, we take a nice big step jump at 24 and another big step down at 2029. But the thing that's interesting, you know, when we phased out the CFCs and HCFCs, production basically went to zero. Under the KIGALI Act or the KIGALI Amendment and the AIM Act, there's going to be a 15% allocation remaining. So there's going to be a service tail out there to make some refrigerants. And so that's good news overall and addresses a lot of the concerns that we saw with the CFC and HCFC phase out. So there'll be a 15% remaining allocation for new equipment or for new production, plus always the reclaimed and recycled refrigerant will be available as well. And again, if we look at this red line, the KIGALI Amendment has different lines for developed and non-developed countries, but you know, the US will follow this red line, and basically the AIM Act mirrors this red line here as the percentages of the baseline consumption. And we used a baseline that was really the refrigerant used back, I think it was in 2011 to 2013 was the baseline of consumption. And the way this works is it's on what's called the GWP weighted basis. So they look at the GWP of the refrigerant times the amount of pounds of that refrigerant produced, and that together is its GWP weighting. So a simple example, if you take a refrigerant like 404A, which was used in a lot of supermarket refrigeration, that is a GWP of 3940. Whereas 134A has a GWP of about 1300. So if a manufacturer had an allowance of 4,000, they could say, well, I could make 1 pound of 404, or I could make 3 pounds of 134. They both meet my 4,000 cap, right? So then it's up to the producers to say which one is going to be economically more advantageous for me to make. But in general, what it's going to do when you do a GWP weighted thing like this, it tends to drive the higher GWP fluids out of the market faster. You know, and then especially before the AIM Act passed and the courts threw out some of the EPA rulemaking, California became very concerned and very active about writing their own rules for HFC phase downs. And the notable thing they've done now is they're online with the chillers January 1, 2024, which is where the EPA is heading. They want to stop the use of refrigerants and other AC equipment January 1, 2025. And then they're proposing to allow an extra year for VRF systems. But when we talk other AC equipment here, this is everybody's home air conditioners, every small packaged rooftop. And basically, this is the 410A market, the bulk of the 410A market that California is aggressively pushing for a 2025 date. They had initially started saying 2023, but realized it technically wasn't possible. But so the question I think here will be, will California stick to that 2025 date? Will it be too aggressive and it have to slip? It may. And I would suspect, depending on where that shakes out, you know, there's a good likelihood that the EPA might try to align its rulemaking for other AC equipment to a date like that. Because right now we're saying, okay, Jan 1, 2024, right? We can't put 134A or 410A in a chiller, but you could put it in any other type of HVAC product and it's still perfectly fine to use. You know, interestingly, KIGALI has been ratified by both Canada and Mexico. The Biden administration has sent it to the Senate to be voted on. It takes a 2/3 majority for us to ratify the treaty. And there's, you know, it's uncertain whether or not that will happen, but we finally at least sent it there to be put up for a vote. You know, as of later last year, 125 countries had ratified this agreement, and it really becomes an official global treaty once the ratification level hit 50 countries. You know, and Canada right now followed some of the original EPA guidance, and they're saying chillers must have a fluid with a GWP of less than 750 by Jan 1, 2025. So they're 1 year out further from the US. But given, you know, the influence that the US market has on Canada, especially when we look at the you know, the industry numbers, the Canadian market on the chiller side is about 5% of what we see in the US. So they're going to often tend to follow what we're doing here because most of the manufacturers have to go that way anyways. I said earlier that, you know, when we look today at products, the biggest impact from use today for a chiller especially is the indirect effect of all the energy that's generated to run that appliance, right? And when you add the direct effect from any leaks plus the indirect effect, you get what's called the total equivalent warming impact, or essentially a life cycle climate performance measure. And that's true today. Even with the higher GWP fluids, the bulk of the impact comes because most of our grids are still fossil fuel based. Now this mix will change, and as we drive towards more renewables, you know, the direct effect will become more important. But if we looked at a study, and this was for a residential AP with R410A and one with R32, and you can see in both cases, the indirect effect of the electricity consumption was by far the biggest contributor. The direct effect is essentially leaks, is the light blue stuff here and here. And then you've got end of life type things. But, you know, so this is big, but as we can drive to renewables, you know, theoretically, at some point, we could get the indirect effect to go away. And then if you're on a low GWP direct effect, we'd have a significant impact for the climate. Excuse me. So if we look at the alternatives, you know, the first place we usually start is with some ASHRAE documentation. And there's an ASHRAE committee called the Standard 34 Committee. And these are the people that actually look at chemical compositions of refrigerants and give them their names and number designations. So when we start looking at new compounds, it gets a number designation, and then it gets a toxicity and a flammability classification. And that's important because that drives a lot of how these things are treated by building codes. So if you look in ASHRAE 34, there's a refrigerant group, a refrigerant safety group classification where you've got increasing toxicity on the bottom. So an A is lower toxicity, a B is higher toxicity. ASHRAE never says non-toxic, just lower and higher, because, you know, in the right instances, water can kill you. You can drown in it. And then on the flammability, you've got a 1 is no flame propagation up to a higher flammability of a 3. And, you know, the thing that happened that changed back in 2016 with the recognition of the properties of some of these new HFOs, ASHRAE added a lower flammability category called 2L to this matrix. And so there was recognition that these things were difficult to burn, but they still could burn. So they weren't necessarily like a traditional 2, but you couldn't classify them as a 1. So the real struggle has been since then is how do you recognize this 2L category in the North America building codes? And it's starting to happen now. ASHRAE's actually, you know, recognize the 2L refrigerants like in standard 15, and some states are starting to adopt it, but overall it's been a pretty slow process. You know, so when we look at how you get new refrigerants into the code adoption process, we have ASHRAE 34 do their thing, and then the EPA also has to approve the use of that refrigerant for that specific application under what's called their SNAP program. And this program really came about back in the 90s when we started doing the phase out of CFCs and HCFCs. But once you have a standard 34 and SNAP approval to use it, then we start looking at the safety standards from ASHRAE 15 to UL, that type of thing. And then when that's pretty well defined, it goes into the model building codes. And from there, then it has to go into the state and local building codes. So we're really still, in a lot of cases, in this model building code stuff. Some states permit the use of it. And, but again, it's been a slow process. But I think, you know, one of the first places we'll be able to more easily apply a 2L fluid is in a chiller, an air-cooled chiller that's outside. Because chillers are considered indirect systems, because if that chiller leaks refrigerant when it's outdoors, right, it either goes outside or it goes into the water loop. If the chiller's indoor in a mechanical equipment room, that equipment room is not considered the occupied space. So it's considered an indirect system, so a bit lower risk. And the EPA has already approved a number of these, some of these different refrigerants, and these are all pretty much 410A alternatives here. So they're lower flammability 2Ls that the EPA has approved for specific applications with specific use restrictions. You know, and if we look and color code that ASHRAE matrix, you've got your A's and B's, your 1s. I put in some common refrigerants that most people recognize, right? Propane, it's actually a pretty good refrigerant. Isobutane is another one. And there's going to be a lot of use for them, but there'll be strict limits on how much charge can be in the system. But we'll see propane and isobutane like in vending machines, refrigerators, things like that. And then you've got ammonia. Ammonia is slightly flammable, but you know, it's got a higher toxicity, so it falls into that B2L category. Then we had 134A, 410A, R22 were all in the green box. 123 was not flammable, but it was higher toxicity, so it ended up in the B1 box. You know, and ideally, we'd love everything to be in the green box, right? But we don't think that's going to be practical when we start looking at some of the refrigerant alternatives. So if we look at this box, the first couple of new HFOs you'll see is a R1234YF, HFO 1234YF, and another one, 1234ZE. And these are the longer term alternatives to 134A. And they're both pretty good alternatives for what they're used for. But you can see that they fall into the 2L category, so it's going to take some considerations of what the impact is in building codes. The 1234YF gives you about the same capacity as 134A, but is not quite as efficient. But this is the one you're typically going to see in your automobile AC now, because since the capacity is similar, that compressor under the hood doesn't have to get any bigger. In the HVAC world, we're more interested in the 1234ZE because this has efficiency similar to the 134A, but if you just drop it in a 134A system, you can lose up to about 25% of your capacity because you have to circulate a little higher CFM per ton of cooling than you did with 134A. So what that means is to use ZE effectively, you're going to have to redesign compressors to maybe make an impeller bigger, make a screw longer, that type of thing, to pick up that extra CFM and recover that capacity. But long term, you'll see both of these refrigerants used quite a bit. And because of the 2L category, there's a bunch of blends that have been put together out there. And generally, these blends are designed to be close to 134A. And the basis for them is usually taking one of these two refrigerants and mixing something in it that isn't flammable to move it from the 2L box to the 1 box. And, the ones you'll see most often today are 513A. And the other one that's going to garner the most interest going forward will be the R515B. The downside of most of these blends is that they're generally not as efficient as 134A was. So there's some impact there. And we kind of see these as maybe interim steps till we get up to the ZE type of products. When we start looking at R410A, one of the alternatives is R32. It's a, it's not a super low GWP. It's much lower than 410A was. And it's already in use in a lot of places around the world. And actually, 410A is a blend, and it's 50% R32 right now. So R32 has been around a long time, and this is one of the more interesting compounds to replace 410A in new equipment. And then the other one that's garnering the most interest, probably that you'll see the most of, is R454B. There's a 452B, but the 454B is the one that's probably more likely. And again, these are mixtures. They have generally from 50 to 70% R32 with some other things in them. And they're tried to be blended to be similar in displacement to what the 410A was, to make a transition to that product a bit easier. And then there's another blend out that's actually interesting that Honeywell introduced called 466A. And what's interesting about this is it's a potential 410A alternative that falls into the green box. The big issue is there's iodine in there, and there's a lot of chemical and material stability and compatibility concerns that people are working on right now. When we get over to the B1 box, there's another refrigerant, R514A, that was really engineered to be similar to R123. So the same low pressure, slightly less capacity, but could work in a new 123 machine and could be retrofit into an existing 123 machine. And then one of the more interesting compounds that's come out is there's an HFO 1233ZD. And this is one of the few HFOs that actually falls into the green A1 box. And this is a new equipment alternative to 123. It's considered low pressure, but it's higher pressure than 134 or than 123. And so the heat exchangers have to be designed above 15 PSI. ASME exempts any shells below 15 PSI and below from having any type of code stamps on them. HFO 1233 will have a design working pressure of about 45 or 50 PSI. It will still operate in a vacuum in the evaporator when it's running, but the shells will have ASME code stamps on them. So it's kind of an interesting product, but given its A1 category, it's a product that's coming to the market from a number of manufacturers right now. So if we focus in on the 134A alternatives, you can see here's 134A, its classification, and its GWP based on the fifth assessment. So what I put here is ideally, if you're going to a different thing, you'd like a green here, you'd like more efficiency, more capacity. We're not really getting that with 134A. You know, the closest thing we can get here on efficiency is really we get to about the same with ZE, but you've still got a capacity issue. And then 515B, you can look at it, this is 91% in ZE. What they did is they added 8.9% of this refrigerant to move it from a 2L category to a 1. And the impact is the GWP goes from 1 up to 292, but you can still get a fairly low, you know, less than 300 GWP now with a non-flammable refrigerant. But today, you know, we still like our 134A. Our 513A is becoming available, and you get a bit of a GWP reduction, but you're taking a bit of an efficiency hit too. And, you know, I'm not sure it's really a good trade-off. And we see 1234 ZE being the product that new equipment will be designed around. And then you'll always have the option with the ZE equipment to put in the 515B if somebody wants the non-flammability, and they just have to take a bit of a compromise on the GWP. You know, and this was just some chiller testing done way back in the day on 513A. But in general, you're going to see probably a 3 to 6% efficiency hit when you go from 134A to 513A. So you get a lower GWP, but it may not have a lower impact. And I kind of see 513A being like 407C was when R22 started going away. It'll be here maybe for a little while, but I really see the ZE as being the long-term product, kind of like 410A displaced R22. You know, and we're already seeing it in Europe, because Europe is quicker to embrace slightly flammable refrigerants. So, you know, 515B, here is a ZE chiller that was sold for a pharmaceutical. Here, Carrier announced that they're putting R515B in some of their products. So we've seen a lot more of this stuff move a bit quicker in the European market, and we're going to get there. It's just not quite as fast. You know, on the low pressure centrifugals, we talked about this a little bit. You know, just relative to the 123, the 1233 is about the same efficiency. You get more capacity, and now it's an A1. Where the 514A, again, is about the same efficiency, but you lose a bit of capacity, and it's still the B1. And so what we're seeing is, I think 1233 has also got some nice properties as a foam agent and as a solvent. So I think that we're going to see 1233 end up being kind of like R11 used to be as the main refrigerant used in lower pressure centrifugals. And the 410A one, this one's a bit more interesting. So we've got the 410A here. And again, it's got a relatively high GWP, right up around 2000. But you can see that it's 50% R32 and 50% R125. And basically the R125 was added to make it non-flammable. You know, and back in the day, there used to be a 410B as well. It was kind of like VHS and Betamax, but ultimately the 410A was the one that was uniformly adopted by the market. So the key alternatives we're going to see going forward are the R32, which just in a disclosure, Daikin has used quite a bit globally. And you can see it's an A2L. It's got a GWP of 677, so it's not great, but it's below the 750 regulatory thresholds we're seeing. The nice advantage of it is you get actually more efficiency and more capacity than you got with 410A. 454 is the other one you'll see a lot of. Its big advantage here is its GWP is a little bit lower at 466. It's about 70% R32, and the rest is the R1234YF. Efficiency is similar to 410A. Capacity is a little bit less. And then this wild card is the 466. Whether or not this will make it as a good refrigerant, and it comes in under that 750 GWP threshold. But then when you look at kind of equivalent charges, the 466 actually needs a bit more charge for a given tonnage. R32 needs a bit less. So your effective charges change a little bit too. And the problem is today, we're still struggling with the code issues and the acceptance of the 2Ls. So today, 410A is still really the only game in town for this type of equipment for the most part. And we'll see 466 continues to be under evaluation. When you look at the double greens, that's an advantage for the 32, but the disadvantage is you really have to redesign your compressors and your combination of compressors and heat exchangers to take full advantage of it. Whereas 454, from a capacity standpoint, behaves more like 410A. So it may be easier to transition existing 410A designs to 454B designs simply by compressor and oil changes and everything else. But I think going forward, the R32 and the 454 will both be used quite a bit by different manufacturers in the same or even different applications. So that's one where it's going to be interesting to see how the market ends up playing out. So what I put together here for you is just a summary. The green ones are kind of the 134A likes. So you get a classification of ASHRAE, what its GWP is, and if it's a blend, what it's made up of. And then I've also got another column here called the temperature glide. And what you'll see is some of these refrigerants have a number like this with a small a on it. 1, 2, 3, 4. And then you have some numbers with a capital letter. And in the ASHRAE designation, if a refrigerant has a 400 or a 500 series number, it's a blend. And then generally at the end of those blends, they have capital letters to designate, if it's a slightly different blend, right? And in the ASHRAE designation, if it's a 500 series, it's been determined to be what's called an azeotrope, which just means in that specific blend, it behaves as a single working fluid over a pretty wide range of temperatures and pressures. So even though, for example, R513A is a blend, you can pretty much treat it as a single working fluid because it doesn't have any what's called temperature glide. And the temperature glide basically is just a measure of how much a blend will fractionate or separate if it's in a pool of boiling, right? Because the refrigerants will boil off differently with different vapor pressures. And as that evaporating temperature changes over the course of boiling that pool, the amount of change is what's called the temperature glide. And the higher that changes, the more volatile the mixture is. What's interesting is we use R410A all the time, right, as a single fluid. But under ASHRAE lingo, it's technically considered a blend, but not an azeotrope. But you can see it as a relatively small glide of 0.2 degrees Fahrenheit. So for all practical purposes, we can treat it like a single working fluid. But when you get to some of these other refrigerants with higher glides, they may not be suitable for use in flooded or falling film evaporators because of the potential for the fractionation. And then you can see the low pressures, both the 1233 and the 514 are considered zero glide. You can see the 514 is a blend, and that's what it's made up of. And I just put the 125 here for interest because that is 50% of what is in 410A. And with that higher GWP, that's what's driving that higher number up closer to 2000. But if you look at the refrigerants on this chart, it's pretty likely that any of the stuff we have going forward is going to be using one of these refrigerants here. as we get rid of the 410A and the 134A. We look at the market activity, like I said, we've got Carrier, for example, choose R32 and scroll chillers, but they picked R54B for their ducted, more unitary light commercial AC. Train is doing trials on the 466A. Daikin adopts R32. We see 1234 ZE in factories. JCI is using 454B in Europe. Lennox specs R32. So we're going to go from a market, especially in the 410 market, where everybody's using the same thing, to where, there could be at least probably two, the R32 and the 454B, becoming pretty common in the market. And time will tell to see if the 466 gets there. We're seeing more 32. We're seeing a lot of new centrifugal introductions using 1233 ZD. And we're going to see a lot more use of ZE. We see it a lot in Europe in both screws and centrifugals. And eventually that's going to come to the market in the US. And again, like I said earlier, on the A2L refrigerants, one of the easier places to apply them will be in air-cooled chillers that are sitting outside. And this was another 1234 ZE chillers. And again, very low GWPs, so there's a lot of interest, but you just have to make sure you can deal with the slight flammability in a safe way. So, what are the best choices for equipment today? We're getting close to that Jan 1 2024 date. I still think 134A is probably a better choice than 513A, but most manufacturers now will give you selections for both and pricing, so you can make your own determinations. 410A is really still the only game in town. There's not a lot else out there. And there's a bunch of 1233 machines hitting the market. But it really gets back to the things we've said for years. You want high efficiency and you want to contain that refrigerant. And as the 2L work gets done, we'll see the 32, the 454, and the ZE coming with more equipment solutions. And that's about it, unless we have any questions, Kelly.
There are, actually one just popped in. Have there been any notable life safety incidents related to the use of 2L refrigerants?
Not that I'm aware of. There's been, a number of tests, and in general, the 2L refrigerants require an open flame to sustain the ignition. But the only things I'm aware of have been things with testing. And right, that's really a concern, because if you look at especially a residential air conditioner, in a lot of places, you can have an A coil above a furnace in a closet, right? So it can kind of be your worst case of having a contained space. So I think the future of using A2Ls is there's going to have to be more monitoring, refrigerant detection on board, and additional safeties that we typically haven't used with some of the A1 refrigerants.
All right. If anybody has any other questions, put them in the chat, or you can come off mute and ask. All right. Well, you can always follow up with anybody at Veritech if you do have any questions. Like I said, I recorded this, so I'll be sending out an email with the recording and the slide deck that we just went through. Please check your messages on this chat feature. I sent you a message if I could not figure out who you were. So if you do need PDH credit, make sure you check that and tell me what your name is if your name is not obvious to me. But that is everything we have. Bill, thank you so much. And
Thanks,
thank you everybody for attending.
And let us know if you have any questions.
I have one question.
Oh,
Yes,
yeah.
sir.
As far as the refrigerants coming out with different housing units, like we have outside units for our housing, are the changes going to be like a whole new unit change out, or just a refrigerant rebuild?
That's a good question. And if we go to the 2L refrigerants, the slightly flammable refrigerants, UL regulations and most local codes will not allow a retrofit from an A1 refrigerant appliance to a 2L appliance. So anytime we go to these new slightly flammable refrigerants, it's going to require new equipment.
Okay.
And that's why there's some interest on this 466, right? Because even if you had to put in new compressors and different oil additives, would that be a potential that you could change the compressor and still make the system work? But in most cases, if you're going away from a 410A system to either R32 or 454, you're going to be stuck having to put in new equipment.
Okay. And that would, new equipment would avoid contamination from the old refrigerant?
Yeah, and just the UL listing and testing, they don't want somebody to go and take a machine that was labeled and certified for use with a non-flammable refrigerant and then put a slightly flammable refrigerant in it, because it kind of isn't compatible with the baseline approval that equipment was made under.
Okay. Thank you.
Sure.
Great question. All right. Let's see.
Kelly, I got a question.
Yeah, go for it.
I just, in looking at this, it looked like there's a lot of different refrigerant types. You made mention of different manufacturers kind of experimenting with different refrigerants. With regards to the new EPA regulations coming out in 2023, are you guys seeing a specific type of refrigerant that most manufacturers are going to kind of streamline across the board? Or is this like still kind of in beta where different manufacturers are still experimenting in the different refrigerants that they're going to roll out in order to comply with the new EPA guidelines for 2023?
Well, I think it's, the chiller date is Jan 1, 2024. So that's the first one that has to be addressed. And I think, for the best long-term alternative for 134A, for example, is 1234ZE. The short-term option is 513A. So you'll see that pretty much universally across most 134A applications. On the low pressure side, you'll see the Train was using the 514A. They also offer the 1233ZD. The other manufacturers are pretty much looking at the 1233ZD if they're going low pressure. So you'll see maybe two different refrigerants there. And then on the 410A, I think the majority of stuff you're going to see is R32 and R454B, maybe the 466 if they can figure it out. So, I think the 134A one's probably the clearest as to what the best alternative is. And it's a bit more of a toss-up on the other ones.
Gotcha.
All right. We have a couple more questions. First, they said, great presentation. When's the next one? So just me plug that real quick. July 13th will be our next webinar Wednesday. We're going to be doing a 3-part series on 100% outside air systems. So part 1 in July will be outside air with VRV systems. So get that little plug in there. Next question. Will there be a major cost difference in the new refrigerants?
Well, today we see it. I mean, the 513A on the OEM side is significantly more expensive than the 134A. Out in the marketplace, though, the pricing difference isn't so great. But yeah, anything that has one of these new HFOs and there's some IP tied up around these refrigerants, and they're going to tend to be a bit more expensive. So unfortunately, I think we will see that it is a bit more expensive.
That is all the questions in the chat right now.
Okay.
I'll give it a couple more seconds if anybody wants any other questions. All right. Oh, there we go. Any foreseen change about the compressor oil?
Well, that is one of the questions that people are looking at, but in general, most of these HFOs are still going to take one of the synthetic oils, either a POE or a PVE typically. And The 1233 ZD, on the other hand, has a teeny bit of chlorine in it, so it can actually work with a mineral oil, which is interesting for the low pressure machines. But on the positive pressure stuff, though, the oils are going to be pretty similar to what we've seen with 410A and with 134A.
All right. Just a bunch of thank yous and great presentations in the chat now.
Well, thank you very much, and I appreciate your time.
All right, we'll go ahead and wrap it up. Again, if anybody has any more questions, go ahead and reach out to us directly and we'll make sure your question gets answered. Thank you, Bill, and everybody have a good day.
Thank you.
Thank you, Bill.
Thank you.
You're welcome.